Dear students, in today's presentation, I am going to continue with the chapter 4, which is a motion in a plane. So, consider this illustration. So, this is one of the field events in sports, and as you all can see, this event is called the javelin throw, in which an athlete throws an object, and that object we call it as the projectile. And see the path in which this projectile moves. It moves in a curved path. So, you take one more illustration, and in this illustration the athlete is going to throw an heavy object, and this is called the shot put event. Even in this event, the object moves in an curved path. So, see the third event, in which an athlete is going to throw a disc, and this is called the discus throw. So, even in this event, the object which we call the projectile moves in an curved path. So, in the fourth illustration, so you will find an object when it is dropped, it moves in a curved path and it falls on the floor. So, this type of motion is called as the projectile motion. So, what is a projectile and what are the example for the projectile? So, question that has appeared twice in the examination. So, any body which is thrown into space which moves under the effect of gravity is called as a projectile. So, what is a projectile? Any body which is thrown into space which moves under the effect of the gravity is called as a projectile. So, example, a shell which is fired from the gun, or a javelin or a shot put or a discus thrown by an athlete is an example for the projectile motion. So, let us learn more about this motion, and there are a lot of derivations are there, there are a lot of numericals are there, so which we will be solving in different classes. So, you take again one more illustration where, so we have a football here, and there is an player who is going to kick the ball like this, and as it moves in a curved path like this. This is the curved path in which the football moves, and the path in which this ball moves is called as the trajectory, and the shape of the trajectory is a parabola. So, this shape is called as the parabola, and when it is projected with a certain velocity, and this is the direction of projection. This is the direction of projection, and it is projected with a velocity u, and this is called the velocity of projection. So, here u is the velocity with which the projectile is projected, that is what is called velocity of projection. So, when there is certain velocity, it moves in a curved path and then it lands on the ground at this particular point. Now, when it is projected, the direction of projection makes certain angle with the horizontal, which is represented by theta. So, here theta is the angle between the direction of projection and the horizontal at that point, and this is called the angle of projection. So, the angle of projection can be 30 degree, 45 degree, 60 degree, it can have any value. It can be as small as 1 degree, 2 degree. So, theta is an angle measured in terms of degrees, and it is always measured with the horizontal. Now, as the projectile is projected, it reaches a certain height here, and that is the maximum height reached by the projectile. So, what is maximum height? It is the height at which the velocity of projection is horizontal. You can see here, when the projectile reaches here, its velocity is exactly horizontal, and that height is called as the maximum height. So therefore, the maximum height is the height of the projectile at which the velocity of the projection is horizontal. As the projectile moves from the initial point to reach that maximum height, it takes certain time, and that time is called as a time of ascent because it is ascending. And then again it takes same time to reach the ground, that is called as a time of descent. So time of ascent and the time of descent are both equal. If time of ascent is equal to 2 seconds, then the time of descent is also equal to 2 seconds. By then it covers certain horizontal distance, and that maximum horizontal distance is denoted by r, and it's called the range of the projectile. So what is the range? It is the maximum horizontal distance covered by the projectile is called as the range of the projectile. Now when the projectile completes the range, it takes a time equal to twice t, because this is a t, again small t, and that is the total time taken to describe the range, and this is called the time of flight. So time taken to describe the range is called as the time of flight. So these are the certain terminology used related to projectile motion, and you have to remember them because we are going to use them often in the derivation as well as in the numerical. So let's see some more theory of it. So what is the trajectory of a projectile? The trajectory of a projectile is a parabola. What is angle of projection? The angle between the direction of projection and the horizontal at that point is called as the angle of projection. What is range of a projectile? The maximum horizontal distance covered by the projectile is called the range. It is denoted by capital letter R. What is time of flight? Question from the previous exam. The time taken to describe the range is called as the time of flight. What is maximum height in projectile motion? Again a question from the exam. The height at which the velocity of projectile becomes horizontal is called as the maximum height of the projectile. So consider a surface, horizontal surface, and at point A, a projectile is projected so that it reaches the maximum height of point B, and then it reaches the point C. Now at A, u is the velocity of projection, theta is the angle of projection. Projectile motion is an example for two-dimensional motion because it moves horizontally, at the same time it moves vertically. You can see as it moves along the horizontal, its height also continuously increases. So that's why it is called two-dimensional motion. As it moves, what is its velocity along the horizontal? What is its velocity along the vertical? What is the nature of motion of the projectile along the horizontal? What is the nature of motion along the vertical? So all that we can understand from this particular diagram. So first we are going to resolve this vector into components. We are going to split into components, one along the horizontal and the other along the vertical. Along the horizontal, u is resolved into u cos theta, and along the vertical it is resolved as u sin theta, and it's taken as ux. Now here ux stands for initial velocity along the horizontal, uy stands for initial velocity along the vertical. As the projectile moves, it is under the action of gravity. A constant force is acting on the body in the vertically downward direction, and due to that, its nature of motion along the vertical is uniform acceleration. So, the force acts only along the vertical, not along the horizontal. Along the horizontal, there is no force that acts on the projectile along the horizontal. The force acts only along the vertical. And so, since no force acts along the horizontal, the nature of motion of the projectile is uniform velocity. So, that is the first point which we are going to analyze. So, what is the nature of the motion of the projectile? Along the horizontal, it moves with uniform velocity. Why it moves with the uniform velocity? Because the force acts along the vertical, not along the horizontal. That is why along the horizontal there is no force, there is no acceleration, and no acceleration means the body moves with uniform velocity, that is along the horizontal. Along the vertical, the gravitational force acts, and when the force acts, definitely there is acceleration, and the kind of the acceleration which is acting on the body is uniform acceleration. So, projectile motion is a combination of two types of motion. One, uniform velocity along the horizontal, and uniform acceleration along the vertical, and this combined motion is called the projectile motion. What is the acceleration of the projectile along the horizontal? Along the horizontal, since it moves with uniform velocity, there is no acceleration. So, acceleration is 0 along the horizontal. What is the acceleration along the vertical? Along the vertical, the force that is acting is a gravitational force. So, that is why the acceleration is an acceleration due to gravity, and it is given, you can see a suffix y. Y stands for the vertical axis, and minus g, it is actually plus or minus g, but it is written minus g because as it moves upward, the acceleration is negative. So, that is why it is minus g. What is the initial velocity at A? So, at A, the initial velocity along the horizontal is u cos theta, and along the vertical it is u sin theta. And when the projectile reaches point B, here the velocity is exactly horizontal, the velocity is not 0, because if the velocity is 0, the projectile will fall here. So, that is why at B the velocity is not 0, it has horizontal velocity, and since the velocity is exactly horizontal, there is no vertical velocity at B. So, the velocity at B is equal to Vx, that is equal to u cos theta. So, initial velocity and final velocity both are same. Why they are same? Because the body moves with uniform velocity along the horizontal, there is no acceleration. So, that is why whether it is at A or whether it is at B or anywhere in the path of the projectile, the horizontal velocity remains the same, which is always u cos theta at each and every point, that is along the horizontal. So, along the horizontal, velocity at each and every point is u cos theta only, because the nature of motion of the body along the horizontal is uniform velocity. So, what do you mean by uniform velocity? Same velocity. Whereas, the velocity at B along the vertical is 0. So, when the projectile reaches B, there is no vertical velocity, it is only horizontal. That is why the final velocity at B is 0. So, hope you have understood. These points are important because we will be using this data while deriving few equations. So, what is the nature of motion of the projectile along the horizontal? Uniform velocity. Why? Because there is no force along the horizontal. The force acts only along the vertical, that is why the nature of motion of the projectile is uniform acceleration. And what is the value of that uniform acceleration? It is y is equal to minus g. Why this acceleration is 0 here? Because there is no acceleration, the body moves with uniform velocity. What is the initial velocity at A? It is ux is equal to u cos theta. So we get this by resolving the vector. So for which you should understand resolution of the vector, splitting of the vector into components. Then what is the velocity, initial velocity at A? It is uy is equal to u sin theta. What is the final velocity at B? The final velocity at B is u cos theta, and there is no vertical velocity, that's why it's 0. Which component of velocity is a constant in a projectile motion? So question from again one of the exam, and the answer to this is it's along the horizontal. So horizontal component of velocity remains constant in projectile motion. And why it remains constant? Because there is no force, there is no acceleration along the horizontal. Which component of velocity varies in a projectile motion? So that is vertical component of velocity varies with the time. Why it varies? That is because of the acceleration, because of the acceleration due to gravity, because of the force, that is the gravitational force which acts along the vertical. What is the direction of velocity at the highest point of the trajectory? So the direction of the velocity at the highest point of trajectory is exactly horizontal. So students, I hope you have understood the basics that I have explained today regarding the projectile motion, and all these basics are very important. Only then you will be able to understand the next topic. So that's why I revised this topic very thoroughly. I will continue the rest of the projectile motion in the next class. Thank you.